in this sense, statistical computing. Statistical computing using C++ programming is prepared and is ESC statistics course. Sixth semester. And evolution of the C program and the basics. Mathematics consists of the control structures and control parameters and strings. Third, structure and block 4, which is consist of classes and objects and inheritance and the polymorphs and the previous question paper. So this is a overall idea about it, what we have in the syllabus. And so we discuss about the programming design and evolution of the C program. Now, today we will discuss about the black one. Regarding the black one, here we have that is a C++ program design and evolution of the C language and the basics of the C languages. Now, in this concept, it is a programming in the objectives is a objectives introduction and definitions and examples of algorithms and flowchart and structured programming summary and model question papers we will discuss today. And in this precises rules and specific how to solve given problem. Is we give that is a one of the algorithm is not in a related to the computer language. In the sequential instructions which we give in the sequential instructions which we will give to the it is a computer. Every program can be solved by using the computer. It can be represented by the algorithm. That it generally it is a language independent. It is a older programs. We have it that is a basics, all symbolic coding languages that are into the Fortran. And that sequential in this it is algorithm is a step-by-step instructions in the sequential order. So flow chart means it is a we give that is what we are the instructions we will do. That is the step-by-step process. It can be next level it go for the locations and go to like statements of how we will be operate and structural languages how we will be used. In this it is a iteration statements how we can be used. These are the overall idea about it. It is the introduction part of the first topic. It is comes to the programming design. In this programming design, characteristics of algorithms. In this algorithm has a following the characteristics. Output. Output is a we may get that is a one or more desired outputs we may get. It is a based on the input. Input what we will give it is a 0 or more well-defined inputs we will give so that we can get the outputs. So it is following the characteristics. One is output, another is an input. Another is any ambiguities. It is each step of algorithm should be clear and unambiguous. Which is a dilemma cases if we have, whether we will take that as a decision, we have a dilemma at the time system cannot be understood. So it is called as a ambiguous. So such should be clear. That is called as an ambiguous. And the finiteness, it is algorithm should be iterations, all will be terminated into the one particular location. That particular point is called as a finite number of steps. That is finite number of steps algorithm is called as a finiteness. And the language independent. And our algorithm should be the independent of the program language. And then here we're writing the algorithm. Here we will go for the step-by-step instructions. Here we have a one more. It is a logics if we want. It is a if-else conditions, closure control instructions. Here loops means it is a do, for, while. Three are the loops we can be used in the writing of the program. Now here I am going for that is a three numbers. I want to go for that adding of the three numbers that will be stored that is in the another variable. So it is a starting for it is a declared the three integers x comma y comma z. And here read the values of and assign into the x and read the values and assign into the y. Add the values of x and y and assign into the z. Print it to start. This is called as the assignment can be repeated with the left arrow. So that is a z is a x plus y is tends to y. Now another algorithm, it is a instruction form. If we give that, it is a rewriting the algorithm. It is addition of the two numbers. Step one, we should write it is a define x, y, z and read the values of x. In the step two, A and step two, B is the read the values of y. And step three is the add these two numbers x plus y that will be stored into the z. So step number 4 is a display of z. So next to stop, the flow section presents some basic algorithms which can be used in the other larger algorithms as building blocks. Find the maximum of the two numbers. That is another example I'm taking. Start. Declare that is the variables are a comma b and read the variables a comma b. Here I want to identify whether it is a maximum or not. A is greater than B. So A is the maximum. That will be displayed. If it's a condition is a else, it is a P is the maximum. When it is a else means it is a when it is a scale. A greater than B is the A. That will go for the else. So else is it is a maximum. Next to stop the program. Now another example, if we take it is a maximum of the three numbers. The maximum of the three numbers, it is a declare the variables A comma B comma C. Read variables A comma B comma C. If A is greater than B, if A greater than C, display that is a as maximum. Else, it is a C is the maximum. Again, else, if it's a B greater than C, it is a relation I am checking from the A and B and A and C. It is a A is maximum in between B and C. Then we can decide A greater than B and A greater than C, so that A is the maximum. Unless we have to go for the decision is a C is a maximum. Or else it is a B greater than C will be checked. Because of it is a B is greater than C. If it is a B is a maximum and C is a unless C is a maximum, that is a else condition. Another example, then it is a stop and finding of the Fibonacci factorial of the number of the given users. That is an example. What is that? We can be take that is a declare the variables of F and F and I. And as the three variables I am taking. Initially, I am giving that is a 1. 1 is starting from the F and F equal to 1 and I equal to 1. 1 also stored into the I. Read the values of n iterations we will take. Repeat the next second step. I equal to n. If F is tends to F star I is tends to I plus 1. It is a display of stop. This is only the idea of the writing of the program for the factorial. The example is finding that is the roots of the quadratic equation x square plus bx plus c equal to 0. Now, here finding of the roots to start and declare the variables of A, B, C, D. 4 variables, R1, R2 and RP and IP I am taking. D, it is the P square minus 4AC. If D is A equal to 0, then it is a minus B plus R minus D by 2A. It is a D is a B square minus 4AC. So it is a minus B plus D by 2A. That is called as a R1, root 1. And the root 2 is a minus B minus D by 2A. It is a root 2. So it is a display the roots are the R1, R2. Next, it is a else. It is a roots. It is a roots are the real and imaginary parts. So RP is clearly real part is the B by 2A and imaginary part is minus B by 2B. Displays the roots RP plus J into IP and RP minus J into IP. Stop the program. This is the overall idea about it. It is a first topic 1.1. Here we have a simple programs and characteristics and writing of the program. Characteristics and writing of the program. It is a definition of algorithm and it's an example. Algorithm means it's a step-by-step instructions. That is a C programming. It is a when we write the program that will be accepted for that. It is a resultant. Now, what is the input we will give? We will get that as an output. So it is a Continuously it will be checked for the here input is a what we will give, output is a one or more. And here ambiguity should be clear. That is the unambiguity will be maintained. Next is comes to the it is the finiteness. Algorithm steps are the finite. Language must be independent. Writing algorithm is a very particular. So these are the steps is called as the characteristics and its respective algorithms. Now I'm going for that is a flowchart. Flowchart means what are the steps we are the process that all we should be write into the graphically or pictorial representation. That graphical representation is called as a flowchart. Here, what are the steps I am writing that we will be represented the graphically. That is called as a different predefined symbols and arrows, so that it is called as a our required flowchart. Here, flowchart is a here overall representation of the different basic graphic steps. It is like a circle, oval, and parallelogram, and rectangle, and diamond, and arrows. These are the different kind of the representations. Why algorithms are generally used to represent the program. The flow chart can be used and anywhere, including that program representation. Flow chart can be used in the representation process of the planning in any area like the business and the education and the hospital. Here I'm giving that is a symbols. Symbols are the here circle, and it is a circle. Circle means it is a symbol is a we will go for that the starting and the ending. It is a inside oval and circle. It is a representation. Next we go for another is called as a rectangle. It is a input is a read and write statement. It is comes to the rectangular boxes. Here no, not exactly parallelogram. Parallelogram representation is comes to the input and the output. And the process means it is a rectangle. Process means rectangle, and the decision means it is a diamond. Diamond will be taken by the decision point of view we will use. Arrows will be the it is a connectors. Connectors means it is a arrows will represent to the connector. Which step to which step we should be given. Example, it is a print 1 to 10 numbers. I have taken one example. Here, print here programming writing point of view, start and initialize a 0 and increment x by 1 and print x so that if x is less than 10, then that it is up to that it is a we should start. So here we can go further. It is a representation. It is a flowchart is a start, and if x equal to 0 and x equal to x plus 1 and print x, and then x is less than 10, it is a arrow will be less than 10, it will be continuous of the process for the improvement. Fine. Now, incremental process. Then after we will go further is a no. Up to 10, it will be over. Then it will be stops. This is overall idea about the program. Next, we go for finding the maximum of the three numbers. The algorithm for the finding that is the maximum was given that the previously, and it's a pictorial representation as a flowchart is given below. One is the start and the view A comma B comma C. And if A greater than B, then it is go for that is a yes. If that is A greater than C, it is go for the yes. That is a print A is a maximum. Unless it is a diamond is representing, it is a left side. No, it is a B greater than C. It is a print B is a maximum. Then it is go for the no. Both are the no. Print C is a maximum. So it is a program is stopped. This is called as a comma B C, which is a maximum. That is a flow chart. Flow chart means it is a symbol. It is a symbolical representations of a circle, rectangle, parallelogram, diamond. So it will be decided whether it will be the incremental to that steps, whether it will be the comparable. You can get that is a result. Next, it is a structured progress. It is a structured programming. Structured programming. It is a also the beginners of all the symbols and the instructions code. It is the Fortran. Now, Fortran will be taken to the C++, Java, everything, all the most of the more modern languages we have. These modern languages we will develop into the various kind of the programs. It is based on that logic. That logic we should be remembered. Based on the logic, your total program will be worked out. Now, here we will go for that is the integer arrays. Arrays means it is a set of instructions. Here we will give in the representation, storage of the elements. That set of instructions all will be the rearranged into the arrays. It is integer of x. It is a main program I am writing in the C language, but that is the average of the even numbers. Average of the even number. That is my program. So here hash include stdio.h and int main. In this argument, say and character star average arg of v and It is an array and a bracket integer x of it is a representation of the numbers 1, 2, 3, 4, 5, 6, 7, 8, so on 10. Int I and sum equal to 0 and cnt equal to 0 and loops and sum and and int n equal to size of x by size of integer. And for I equal to 0, I less than n, I plus plus. And it is a iterated through the array variable. And it is a bracket. Then it is a if x of I is a percentile 2, it is equal to 0. It represents the remainder is 0, it is divided by 2. Then we can go further. It is a sum plus equal to xi added to the sum only if the divisible by 2. It is an even number. Next, count plus plus incremental will be happen. Then it is a count is greater than 0 and average will be taken by that. It is a float of sum by float of count, total number of elements. It is the even numbers, total even numbers divided by total even number of events. So that it is we can get the average of even number. Else there is no even number, so that we will not get any average. That's called as a program. It is a precise rule and specifying the how to solve that is a some program. And through there are the no standards for the writing of the algorithm. Here modern questions it is what is the right algorithm for the sum of the numbers from the 1 to n. That I already explained. It is a diamond, a rectangle, circle. Circle is start or stop. And the diamond is a logic, so on. Now we will go further.